So we saw robots packing a box, moving a box, stacking blocks, and I think making juice. Did you see that? I don't know if you use that in your office. What else are your robots doing on the field today?
The robots are largely doing very simple tasks, material handling tasks in logistics and manufacturing. So it's early days. The way that we think about this is we want data diversity to feed general purpose models. So there's tasks we're going deep on. Those are largely logistics and manufacturing. And then we're starting to sample new tasks where we want to go wide. So we care much more about robots doing a wide variety of things than getting just specific at one thing. But obviously we want them to prove viability and utility is sort of the first phase of this. So we're going deep on those logistics and manufacturing tasks. Still in the pilot stage though, I will say.
And how many of them are out there right now?
There's a handful of robots out there, less than 20 systems that are out there in total, but more increasing over time. So still early pilots. We're ramping this year, and we'll have hopefully in the hundreds next year as we sort of move ahead.
And how are they around humans?
So initially, we don't have collaborative safety standards for these robots today. So there's cobots, which are collaborative robots that are safe to work with and around humans. That was a safety standard that took years to develop. We can leverage some of that. In some ways, humanoids are the same. In some ways, they're different. So the early stages of this, we're not putting them around humans in these, industrial environments. And we're working as an industry to build collaborative standards so that they can work with and around humans safely. And that's going to take time to do. I think fully realize the humanoid robot is a collaborative robot. Clearly, it has to work with and around people.
So in our prep call, you mentioned that you have 16 pilot customers, and some of them are big names. There's Mercedes-Benz and GXO, the big logistics provider. When they come to you, what are they asking for? And I guess why you?
Yeah, I mean, when they're coming, they're asking us to solve problems. So they generally have a specific list of use cases that they're interested in, and they're all facing the same challenges, and that they don't have the people to do the work that they need done. So you talk to all of these groups. If you look at manufacturing, logistics, healthcare, this is becoming increasingly a challenge. They don't have the workers to do the work they need done in the wake of COVID. I think the reason that they pick us to work with, usually there's a big selection process and a down select where they'll pick who their partner is going to be, is one, because of our technology and experience. I think we have some of the deepest experience in the humanoid space. But two, I think because of trust as well. I'm generally honest about sort of where we're at, where the technology's at, and where we're going. And I think that, an interesting thing about these customers is that in the early stages of humanoids, the knock against humanoids was, this is for people that don't know anything about automation. Like if you really know anything about automation, you buy this special purpose robot because these things work. And as this market has developed, that's actually not true at all. The deepest customers we have are the most sophisticated, the savviest consumers of automation. And the reason that they're looking at humanoids is they've tried to solve their labor challenges with existing robots. And what they've ended up is this scattershot, sort of disparate solution set with unique hardware, unique software, unique service providers to service those robots. And it's this mess that they have to manage. And sort of out of that is coming demand, well, what if we could just do all of this on one platform? And so you can argue about time horizon, like how quickly is the uptake going to happen and how fast is this going to move? But these groups have seen enough now that they're saying, look, this is clearly the future. And we're going to make big bets here, and we want to go work with you guys. And it's been an exciting sort of shift in thinking over the last few years.
Now, I wanted to touch on your Mercedes partnership. So you're targeting areas that require low skill labor. Why is that?
Because those are the tasks that we can do today, and I think that those are the most valuable tasks for us to automate early on. So essentially, it's about capability of the robots and what they're capable of doing today.
So what is it that your robots can do, and what is it that they can't right now?
So largely what we're doing is we're teleoperating the robots in these environments. we've shifted a bit of our strategy over the years. So initially, I was focused on doing everything end to end. And if you see any of the videos, we were doing what we call gross manipulation. So full autonomy, the robot can grab a box, it can move it from one place to another, like a two-hand grab. What these foundation models that I'm talking about have offered is the ability to do dexterous manipulation, which if you look at sort of Bureau of Labor Statistics, most tasks that are out there, something like 98.8% of all labor tasks involve some type of dexterous manipulation. So pretty much everything. You can find these simple gross manipulation tasks, but that was never going to be the promise for humanoids. So what we're doing now as we lead into foundation models is we're teleoperating the robot. We can do many tasks, a whole range of things from juicing or making your lunch or whatever the task might be under teleoperation. And then what we're doing is building and training these models to do them autonomously. What I'll say is that the robots are slow relative to humans today. They're somewhat brittle. They're becoming more generalized. But we believe that this is a function of data, where as we have more and more data, especially data out in the field, the robots will get faster. And we believe there's no technical reason that the robots won't be at least as fast or faster than humans across a whole wide range of use cases and applications.
Do you have a particular time horizon for that when it gets faster and better?
Yeah, I mean, we're out in the field right now proving out these use cases. We're going to start with 3 to 5 use cases that we really prove out, or we can do at rate, at human speed. And then we'll sort of grow from there. I think sort of best case scenario is that you have general purpose robots that can do things that you show them. This is called learn from demonstration or zero-shot learning. I show them it once and they can do and extrapolate from that task. I think best case in the next 2 years. I think it's possible. And we're working with some of the biggest companies in the world, the best minds in the field. So I think it's going to come faster than a lot of people probably realize. And I think the frame to think about is all this is not necessarily this quantum leap. It's an integration of things you're already seeing around you in the world today. Commercial drones gave us sensors and motors. Electric vehicles gave us batteries. AI is autonomous driving is giving us pieces of the AI. Then you had large language models and generative AI. And so now we can put all of those things together into what we believe is the ultimate form factor, which is a robot that can do work in our environments and do all the things that we don't want to do so that we can focus on things that we do want to do.
And in these pilots, what are the metrics that you're using or that you're seeing?
It depends on the pilot, but generally it's like the rate of picking. So in logistics, it can be 300 to 400 picks per hour. Sometimes it can be more or less. Depends on if you're in parcel or in third-party logistics company. So the rate that you're picking, and then the failure rate, and then the cost. Those are sort of like the key metrics. Is like how fast can you do a task? How often do you fail? And then price points. And the price points will be dependent on sort of the conversion of these on the other side.
Now, you mentioned in your intro that you're using the humanoid form factor. And I'm just curious, why did you decide to do that and not a vertical form?
Yeah, I mean, I think I mentioned this before, but there's 3 reasons sort of why humanoids. I talked about the economics of robotics and the challenges of where you apply these robots today. So the main thing we want is versatility. The question becomes, how do you get a versatile robot? The challenge with this today is like a robot arm can be versatile, but for every new task that I want to do, I have to change the environment. So the first 2 things we want is versatility and retrofitability. We want a robot that can slot into these environments, can use all the same tools. Humans have a very small footprint, so I'm roughly a square foot and I can reach well over 6 feet. This is a challenge in most robots, and so having it be able to use the same tools and operate in these environments is the first piece. The next piece is how do you train in this learn from demonstration where the humanoid form directly correlates to learning from humans and human data. And if you try to do it with a different type of robot, that's called cross-embodiment mapping, or if you try to learn from a human to a different morphology, that's still an unsolved problem. There's still challenges there. So this is sort of, in some ways, the easiest form factor for us to learn from. I think the other reason is I think it's the most optimistic version of the future. Some people disagree with this, but we're going to have robots. We're going to have billions of robots over some time horizon. And the question is, what do you want that world to look like? Do you want these to be lifeless machines that you're sort of interacting with and around, or do you want these robots to have character and maybe some personality? And I think that that idea is far more exciting than the first way.
And what are some of the biggest challenges for you, both technically and commercially?
Lots of challenges. Sometimes it's better that you don't know what you're getting into, or you might not do it at all. I think right now it's really going from the lab to the real world. So we're not that we're out of the R&D stage, but we have all the pieces now that are necessary to do this. So this is much more engineering execution than this is like research and development now. So operationalizing robots, having them work, maintaining those robots out in the field, these are all real challenges. So these are real like operational challenges, and then data collection out in the field. But I think this is the exciting juncture where this now goes from the lab to the real world.
And do you think you need to prove it out with industrial customers first before it kind of broadens out to other applications?
Yes. I think you're going to see, I used to think it was going to be more serial, like you would start in logistics and manufacturing. In robotics, we call this the move from structured applications to unstructured. So structured means I can control the environment's relatively predictable, and then I'm moving to unstructured applications where the environment's much more chaotic and variable. And it was much more of a challenge to do unstructured things. I used to say like, manufacturing is structured and then your home is chaotic. Now with these models, potentially some of these things will happen at the same time. Like you could have a robot that you just want to talk to in your house that has a large language model, and that might offer some utility. But I think real value in things like the home and elder care is going to take quite a bit of time. And so I think also when you look at healthcare is really looking to other industries to understand how to think about safety. And so for things like humanoids, we can prove these out in manufacturing and logistics where we can separate the robots away from people before we have them interacting to a much higher degree with and around people in things like retail, healthcare, and out in the world.
So again, you're still kind of in the pilot phases with all your customers. How long will you say it kind of takes to kind of get your robots to scale?
Yeah, I mean, we've signed our first POs, I will say, but it's still, I just sort of acknowledge it's in the pilot stage. I think expect the industry as a whole to really be piloting through the next year. There are some humanoid companies that are sort of announcing the move from pilot to commercial applications, but it's still relatively early days overall. So piloting through next year, and then by 2026, real commercial deployments.
Now, there are a few competitors out there. Figure raised $675 million from Microsoft, Amazon earlier this year. How does Apptronik build a moat around itself?
Yeah, I think there's sort of three ways that we stack up, and I think the first is commercial traction. So, I don't know if this is being recorded or not, so I don't want to talk about our pipeline. If someone's interested, I can show you. I think in terms of commercial traction, we have tremendous commercial traction. We have 16 pilot customers. We've signed a significant number of early LOIs. The second piece is our technology. I think one of the challenges in this space, the reason that Figure and others have to sort of enter the market and raise that kind of money is because the challenge in robotics is it takes iteration, and it takes iteration out in the field. And we've already done a lot of that. One interesting point about Apptronik is that we really didn't raise money for the first 4 or 5 years. We bootstrapped a humanoid company. And the way that we did that was by working with customers, by delivering robots, by showing value out in the real world. And that was not an easy thing to do. And so I think, and that's sort of gets into the last piece, which is this is a long game, and it's a long race, and it's the very beginning. And so the capital efficiency that we sort of have in our DNA and our scrappiness, I think is going to take us in the long run. And we will raise significant money. We have some really exciting things that we'll announce here very soon about some big deals and partnerships that we're working on. So it will take capital if you're going to win this race as well.
I'm going to get back to that really quickly. But yeah, if you could just dive a bit deeper into kind of your tech stack and what makes you unique or different.
So I talked about the two things that you need. One of the things that we're known for is these electric actuators. So we've done 50 iterations of these motors. And think of all a robot is stringing together these motors and sensors and then controlling those motors and sensors, right? That's all it is. It's that easy. But so we have a lot of IP around how you build the robot itself and then how you solve a lot of the supply chain challenges around scaling a system like this. So what a lot of people are saying is they're basically pitching the humanoid market and saying, hey, we're building robots the same way we've done it in the past, and there's going to be millions, billions of these things, therefore they're going to be cheap. I don't believe that's true. I think if we could build cheaper robots, then we would have done it a long time ago. The robotics market has been constrained by the cost of robots for some time. And the challenge has been the paradigms we've been building them under. So one of the things that we've done is think up new ways of building these robots from first principles. And I think we're building robots in a very unique way. And we're able to leverage a lot of off-the-shelf components that are already out there. So that's one piece. The second piece is on our AI. We have a world-class AI team. And we also have world-class AI partners. And I think what you'll see us announce here soon is some really exciting and interesting partnerships that are very unique, where we're going to go deep. So both hardware and software, it's both of those things together that I think put us in a unique space.
So it looks like a human, it walks like a human. I don't know if it talks, but I guess it could.
Yeah.
So will this replace humans?
No, it will not replace humans. So humans are tool makers. This is an idea that humans have been chasing for centuries. The first attempt, as far as I understand, was in like 3000 BC in China to create an automata. This is something that Leonardo da Vinci tried to create in the late 1400s, was a mechanical human. So this is something that we've been thinking about for a long time. And I think the meta story is, as humans, our most valuable resource is time. And our time here is limited. And we had great thinkers in the last century that predicted we would use our technology to give ourselves more time. Right? What is technology? Technology is the application of knowledge. And so what should we use our knowledge for? My view is we should use our knowledge so that we have more free time, so that we can spend time with our family, so we can spend time on things that we enjoy doing. There's this adage, well, somebody's got to do it. And there's this structural incentive, I believe, to keep people doing things that we need them to do, right? There's a whole history in the South, where I come from, of sort of, what happened there. And my view is that as you put robots on the bottom layer of society, what hopefully happens is that you elevate humans to do new things. You free them up to sort of have more creative jobs. And another point here about sort of replacing humans and replacing jobs that I think it's an archaic view to think that the robots are going to replace jobs one-to-one. If you take nursing, for example, there's a great company called Diligent Robotics, and I got this from Andrea, so I want to give her a shout out. But if you have this nursing shortage, by 2030 we're going to be short 13 million nurses. Sort of, elementary view of this is that you'll have robot nurses. But do we want robot nurses? We value human-to-human interaction and care. So a more interesting question is, why do we have a nursing shortage? And the reason we have a nursing shortage is because 60-70% of a nurse's job is doing something that has nothing to do with their clinical training. So they go to school for 4 years, they pay all this money, and then they're changing soiled bed linens and fetching stuff from the pharmacy and running errands and filling out paperwork. And that is very demeaning to these nurses, and it drives them out of this work. They don't want to do it. So what if you pair a nurse with a robot such that the robot does all of the worst parts of those jobs, and that elevates the type of work that nurses can do, the work that they care about. They can deliver better patient care. I think this is a framework to think about how humans and robots can coexist in the future, such that think about your job in general, and what if a robot could do that? And what if you didn't have to do that? And there's huge sort of implications. There's a lot of unquantified implications of this. I mentioned in the beginning, the biggest markets for this are going to be elder care. We're all getting older. I looked at my granddad and both of my granddads, and they never relied on anybody for anything. And at the end of their life, they had to ask people for help. They were a burden to their family. They felt like, my granddad told me that. He felt like he was a burden to his family. My view, my optimistic view of the future is that I can build a robot for my parents, hopefully first, that they can rely on, that does things so that they don't have to rely on other people. They can maintain their independence. They can improve their quality of life. And I think that if we can do that, that'll be one of the most important things we can do to improve the human experience.
And just on that, what are the hurdles that you, I guess the industry needs to kind of jump over in order to get, I guess, robots accessible and affordable and in a home?
I think there's two pieces, is that, I mean, we will need volume to drive the home robots, but also capability. The robots aren't good enough to go in your home and do anything more than a novelty. Some people want them, and that will be cool to have a robot, but they're not good enough to, everyone wants them to do their laundry, so do I, but they're not good enough to sort of do these things. And the challenge is, if, say, a robot does your laundry and does your dishes, that's maybe, how many hours a week is that for you? Like, and then what is the price point you'd be willing to pay for a robot that could do those sort of main tasks? And so I think the costs are going to continue to have to come down, and the capability will go up. And I think we're getting the hook from the stage here.
That's great, because my last question is, you mentioned that you have a couple of big announcements. Is there anything that you can tease for this audience?
I think what you're going to see is there's certain things that startups can do very well, and then if you look at the big AI race, it takes significant capital. And so I think the thing that I always think of is, how do we work together, and how do we leverage our strength, and how do we also partner where it makes sense? And so I think not just with us, but across the space, you'll start to see some big announcements of new and exciting collaborations that are going to take us on to the future.
Great, thanks, Jeff.